Okay, guys. So this is a continuation of the hard problems. So determine the minimum angle of rotation for A to map onto A prime. Oh. I just realized that I was showing a couple people the wrong way to do it in class. Yeah. Okay. Yeah. What I showed them was I just got the minimum angle. So this has let's call them spokes. It's got 8 spokes. 1 here, 2, 3, 4, 5, 6, 7, 8. So this has a symmetry. This has 8-fold symmetry with the. Sorry. Well, what I mean to say is like it's kind of like an octagon. It's got you can, to find the minimum rotation, you can do 360 divided by 8, which is 45. And that's what I had told the students in the class was the answer. But that's not the answer. That's not what they're not asking for the minimum angle of rotation. They're asking for the minimum angle of rotation for A to go to A prime. Now, we're going to need the 45 degrees. We need this because what that's telling us is that to get this little point A to move over here so that this, let's call it a saw, like the saw that the guy outside is using right now. To get this saw to land back on top of itself, you would need to turn 45 degrees. Okay. Now, as far as what they're asking about, which is how do you get A to go to A prime, well, we have to do one 45-degree turn, another 45-degree turn, and then another 45-degree turn. Okay, and that's 135 degrees. Now, that's one way to get A to go to A prime. But what if you said, but Delamo, can we go this way too? Can we rotate 45 this way, 45 this way, and so on and so forth all the way around? And that would have been 225 degrees total. Could we have done that? The answer is yes, you could have done that, but the thing, that's what it means up here to determine the minimum angle of rotation. The minimum angle is 135. That's the shortest way to do it. So it's 135. Okay. Let's look at number 11. Which transformation would not carry the rectangle onto itself? Okay, let's look at the different options. A reflection over y equals x would work. Okay, that would work. B would go to C. Okay, C would go to B. That would work. That's blue. Let's look at a reflection across the line y equals negative x plus 10. So the y-intercept is positive 10, so we can start up here with this graph, or the graph of this line. And the slope is negative 1. So that's down 1, right 1. Down 1, right 1. Down 1, right 1. Okay, so these points. And that would also work. If you reflect across that line, B would end up going over here to A, and A would end up coming up here to B. Okay, so that also works. So let's delete that. Okay, so that's red. Let's do green. A rotation of 180 degrees around the point 6, 6. 6, 6, this is 1, 2, 3, 4, 5, 6. 6, 6 is right here in green. That would not work. 180 degrees would make this rectangle look something like this. That won't work. It won't land on top of itself. So C is the one that sees the answer, it's the one that won't work. Option D would work. Option D is 5, 5, which is right here. And if you rotated the rectangle around that, then it would land back on top of itself. Okay. Number 12. Neither figure is a square. Which transformation can be used to map figure 1 onto itself and can also be used to map figure 2 onto itself? Which transformation can be used? So it has to work for both. Okay, I think the answer is A, so let's look at, I'm sorry, A doesn't work. Okay, cool, so we'll start at A. A says a 90-degree rotation clockwise around the center of the figure. So that means take the center of this figure, rotate it 90 degrees around. Take the center of this figure, rotate it 90 degrees around. That would work. Oh, wait, neither figure is a square. Oh, okay. So, that means it won't work for either figure. It doesn't work for this rhombus on the left, or what? Figure 1 seems to be a rhombus. So, if you rotated it 90 degrees, it would end up looking upright. Okay, so it won't really land on top of itself. So it doesn't work for the rhombus. Okay, let's look at option B. Option B says a rotation of 180 degrees around the center of the figure. That would work, okay, for figure 1. You go 180 degrees, it'll be flipped upside down. It'll be oriented the same way, meaning that the long axis here would still be like that, and the shorter axis here would still be oriented up and down. So that would work. And then it would also work for the rectangle. So it's actually option B. None of the reflections will work. Or sorry, like option D, the reflection over the diagonal, that will not work for the rectangle. I think we talked about it in the, we talked about this in class. We've done this problem in class a long time back. But I also said it in the medium difficulty video, which is that only for rhombuses do the diagonals work. Rhombuses and squares. Okay, so option D would actually work for figure 1, but it won't work for figure 2. Option C, I think, is the opposite, if I remember correctly. So option C says, okay, let's get rid of this so we don't confuse. The answer is B. Okay, I'm just going through C and D just to show you why they fail. So option C says a reflection over line through the center of the figure that is parallel to one of the sides of the figure. That's a little bit hard to wrap your mind around. It says a reflection over a line that goes through the center and is parallel to one of the sides. So that works for the rectangle. Let's try to draw it for the rectangle. It goes through the center and it's parallel to one of the sides. So let's just take this side. Parallel to that would be like this. And that works. This point will get transferred over here, or transformed, I mean, and this one will get transformed over there. Same thing with these two. But that does not work with the rhombus. If you look at the rhombus, through the center, and then parallel to one of the sides. So we can pretend it's parallel to this side. That does not work. Okay, let's go to the next. Number 13. This one I told you guys to do in trial and error. By trial and error, way back. I think that's still the most appropriate way to do it. So, for the options, we have all of these rules. Now, What was convenient about these rules is that you can literally plug coordinates into the x and the y values, and when you go ahead and evaluate these expressions, like half x plus 2 and half y minus 3, you will literally get the new coordinates. So what we're going to do is you're going to choose a coordinate. We'll just choose not a coordinate. We're going to choose a point, B, and look at its coordinates. What are its coordinates? It's 2, 1. 1, 2, 1. 2, 1. So B's current coordinates are 2, 1 before the transformation. And what we're going to do is we're going to plug these points into these various rules and see which one of these rules actually gets us a B prime that lands where it's supposed to. Where's B prime supposed to be? It's supposed to be at 1, 2, 3, 4, 5, 6, comma, -1. So we're supposed to get B prime of 6, -1. Only one of these will do that for all of the points, A to A prime, B to B prime, and C to C prime. Only one of them will do that. Now, in this case, so if you really wanted to be 100% sure of which rule it is, you actually can't just do it for B. You'd have to do it for A, and you'd have to do it for C. But in this particular case, if you try B, only one of them works. Like, only one of these works for B. So we're just going to focus on B. Okay. So I'm going to choose 2 of them. One of them works, the other one doesn't, so you can see what the difference is. But I'm not going to plug it into all of them. So let's focus in on 2 of these here. Let's focus on option B and option D. So I believe the actual answer is B. So we'll do that one in blue, and then we'll do the one that's not in red. And again, I'm just doing one right, one good one, one that doesn't work, just so you can see the difference. Okay, so what do? We got to take the coordinates of B, which are 2, 1, and plug them into this transformation rule. Okay, so now it gets a little bit. 2 times x. What is the value of x? X is 2. So we're going to plug that in there. And then it says plus 2. So we're going to do plus 2. And then comma, comma, 2 times y. So 2 times y. What's y? The y value of B was 1. So we're going to plug 1 in there. And then it says minus 3. So minus 3. Okay, and now we can try to evaluate that. So we're going to end up with 2 numbers. This blue part, 2 times 2 plus 2 is 6. So that's a good start. And then this right hand coordinate, the y coordinate, is 2 times 1 is 2, minus 3 is -1. Okay, so this transformation rule worked for the point B to get transferred to B prime. Now, let's say you had tried out D. What would have happened? Okay, it was the same process. We want to plug in 2, 1, which is the original coordinates of B, and see if this transformation rule would give us B prime up here. 6, -1. Okay, so this rule says you take 2 and you multiply that times the x value of the coordinate. Our x value is 2. And then you do minus 2. And then comma, for the y value, you're going to do 2 times the y value. So 2 times the y value is 1. 1. plus 3. Plus 3. Okay, so this blue part on the left, 2 times 2 minus 2. 2 times 2 is 4. Minus 2 is 2. So we would have gotten 2 here, which is already wrong. You can see that's not where B prime is supposed to be. But anyways, we'll continue. 2 times 1 plus 3 is 5. 5. And that didn't work either. We're supposed to get negative 1. Okay. So B is the answer. Again, if you wanted to be 100% sure, you would actually have to do it to A and to C as well. You have to do the same thing. You take the coordinates of A, which are 2, 4, pass them through plug them into the transformation rule option down there on the bottom, and see if you get 6, 5. And then you take the point C, which is 4, 1, and hope to get C prime, which is 10, negative 1. Okay, it would work for option B. That's the only one it would work for. Okay, so option B is the answer. 14. Okay. 14. Triangle ABC is shown on the XY coordinate plane. It will be rotated 90 degrees clockwise around the origin to form triangle A prime, B prime, C prime. Okay, 90 degrees clockwise. Around the origin, so we can use the rule XY goes to clockwise is Y comma negative X. So switch the coordinates and change the sign of the one on the right. After you switch the coordinates, you gotta switch the coordinates first before you change the sign. Okay, select the correct orientation of A prime, B prime, C prime. Oh, it's not even looking for coordinates. Okay. Well, I guess we can do it anyways. That'll make it easier. So let's look at A. Coordinates of A are 2, 1. So this is A. Whoops, just A. And that goes to A prime, which is switch the coordinates. So we get 1 in the front, or 1 first, and then 2 after, and then change the sign. Let's plot that. Let's make this thinner. 1, negative 2 is right here. Okay, let's look at B. Coordinates of B are 3, 3. When you apply the rule, you switch the 3's, they're both the same thing, and then you change the sign of the second one. 3, negative 3 is down here. So this is A prime, B prime, and then C has coordinates 5, 2. After we apply the 90-degree clockwise rotation, switch the coordinates and change the sign of the second one. 2, negative 5, of course I put the B in the wrong place, or in a bad place. 2, negative 5 is down here. So this is B prime, this is C prime. And if we connect the dots, we get this. Okay, so the question is, which triangle is oriented, or which option has that one? And it looks like it's D down here. Okay. Done. Delete. Last one. Not that easy. So we have to select all that apply. I'm just going to cut that off. Okay. The question says points J, K, and L are distinct points, and JK is equal to KL. Which of these statements must be true? Okay, so option A says JK and L are coplanar. That's true. If you take any 3 random points in the universe, any 3 random ones, you can find a plane that goes through all 3 of the points. And I demonstrated that in class at the beginning of the year. Now, once you introduce a 4th point, so if you had J, K, L, and then M, then it's not guaranteed that you can fit all 4 onto a plane. Okay? And I kind of did it with an analogy. I said, in 2 dimensions, if you limit the story to 2 dimensions and you're thinking about a line, let's draw a coordinate plane. You got a coordinate plane. If I pick any 2 random points on the coordinate plane, can you find a line that goes through the 2 points? And I think you guys were really good at that. You guys said very easily, yes, of course, you can draw this line. And I said, okay, well, what about another random point? Like, let's say the point was over here. And you guys said, yeah, you can draw this line. And I said, okay. Now, what happens if I'm a jerk and I introduce a 3rd point into the situation? So I say, can you find a line through these 3 points? And the answer is no, you can't. Like, there's the line, it can't curve enough to include the 3rd point. So it's kind of similar with this this first option, but in 3 dimensions. So in 2 dimensions, you can pick a line that goes through any 2 points. In 3 dimensions, you can find a plane that goes through any 3 points, but not a 4th one. Okay, so option A is always true in real life. Okay, so let's look at B. JK and L are collinear. Okay, well we kind of just talked about that. 3 random points in the universe, they don't have to be on the same line. They don't have to be collinear. Okay, you can just rewind a few seconds to look at the picture. Okay, so this is false, so we're going to scratch it out. C. Option C says K is the midpoint of JL. This is very tempting because it says we got J, K, L, and the reason that oh wait, hold on. Well, yeah, okay, that'll be good. So J, K, L, and the reason I spaced them out so neatly, where this is the same length as this one, is because they told us JK is equal to KL. So you might think this is true. Option C is true. K is totally the midpoint. But the problem is that the way I drew this was convenient and it didn't have to be drawn this way. I could draw JK and L in another way that still satisfies this, but they're not aligned. So let's draw JK and L in another way. You can draw JKL like this. So here's JKL, and guess what? We still have that JK is the same length as KL, but now we can't even talk about K being the midpoint because this is not even a straight line segment. Midpoints only make sense for line segments, and this whole contraption here is not a line segment. Okay, line segments have to be straight. So when it says, option C says K is the midpoint, not necessarily, not if I drew it like this. So we can, what do you call it? Delete this option. Okay, option D, JK is congruent to KL. It's definitely congruent. That was part of the requirements of whatever drawing we drew, whether we drew it nice like that or whether we drew it like this. Okay, E, the measure of JKL is 90. That's not true. Actually, let me change this color to blue. Let me circle this with blue. Be consistent. Okay, JKL is 90 degrees. Well, what was JKL in here? Oh, this is highlighted in purple. This is purple, right here, JKL. That's angle JKL. Maybe that's 90, maybe it isn't. The point is I could draw it skinnier, or I could draw it wider. Heck, if we had used this example up here, what's that angle? It's 180 degrees. So it definitely does not have to be 90 degrees, so we can delete that one. Okay, so the only answers are A and D. Okay. So, done, delete screenshot. And that's all the solutions for the hard questions for the mid.